You are listening to
Worldwide Engineering.
Worldwide Engineering.
Worldwide Engineering.
Worldwide Engineering.
Hello, Worldwide Engineers. Welcome to this episode. My name is Leon, and it is my pleasure to introduce you today to my podcast guest, Hamza, who is a Google engineer. More specifically, Hamza works as a customer engineer at Google's cloud platform. On today's episode, Hamza and I got the chance to dive deep into the technicalities of cloud computing. What is cloud and how is cloud changing the world? Hamza also got the chance to share with us his experience working at Google and what it took him to get a job at this company. I hope you enjoyed the podcast. Let me know what you thought by sending me a DM on at worldwide_engineering or on my personal account at Leon Abboud. Enjoy the show. I'll see you on the other side. All right. Hamza, thank you for coming. It's been a while. We've been trying to plan this podcast, and I'm glad to have you here, man. We met through a common friend, Boris, who also works in cloud, so do you. For the people that haven't heard of you, do you mind giving us like a brief introduction of what you do? You work at Google, right?
Yes.
Yeah, can you tell us a bit about that, please?
Yeah, thanks for having me, Leon, today. I'm very excited to be here with you and with the worldwide engineer community.
It's a pleasure, man.
Thanks. Just before kicking off this podcast and talking about like technology and cloud computing, I just want to take some time to talk about the Lebanon explosion. So I just want to say we are all in this together. And thank you for sharing the Just Giving link yesterday. For helping our brothers and sisters there in Beirut to provide the disaster relief. I personally used this link this morning. I shared this with my family. So stay strong. We are all in this together.
Thank you, man. That means a lot to me.
Yeah, I can maybe do a quick introduction about me. I was born and raised in Morocco, North Africa. Studied electrical engineering in Morocco, worked on renewable energy projects there because you have a lot of solar energy in Morocco. It's
That's
sunny
cool.
all the year. And then in 2014, I moved to Paris, in France to studying computer science. And I got my master's degree in computer science. And then I worked for different companies like Renault Nissan, the multinational cars automaker, and worked for Orange Telco company. My job for these companies was a cloud DevOps engineer.
Okay.
So you can see three words in the job description, cloud DevOps engineer, right? So we all know who is an engineer. Cloud is for cloud computing. DevOps is dev for development and ops for operations. This is a new job. Like people start using this job title like 5 years ago. So my role as a DevOps engineer was helping developers and operations to work together. Both people categories are looking for different and have a different mission. So for example, developers, they are looking for more speed. They want to release features as fast as possible because they work directly with the product management team. So the product management team, they're asking for more features,
Right.
releasing this as soon as possible to, because they're competing with other companies. Operations are looking for the opposite. So they are looking for stability. They are
Right.
looking for reliability. They really want to make sure that they have a reliable infrastructure
Right.
and making sure that they have a stable infrastructure for serving customers.
That's interesting you mentioned that because I've heard DevOps a few times. Like speaking with my previous interview with Boris, he was saying DevOps, and I had an idea, but now that you say it, it makes a lot of sense.
Yeah, and to make this project a success, you need 4 principles. You need people, culture, process, and technology. This is the 4 principles that you really need to making sure that you are implementing a successful DevOps project in an IT organization. So you need platform engineers, you need DevOps engineers to introduce this culture. You need to bring a culture, maybe asking an operations engineering team to do some software engineering stuff and vice versa. So this is the second principle. You need technology. So you need some cloud services, you need some SaaS solutions, and you need process. Process, you can find something like continuous integration, continuous deployment, continuous testing. So you can implement this kind of process in your company to see how you can continuously release new features and deploy them to production and serve customers. So this is a quick, the overview about the DevOps project and my role working for these two companies before. And then, like 2 years ago, I joined Google for a completely different job. So before Google, I was not a customer-facing engineer. I was an engineer working with developers and operations. I joined Google as a cloud customer engineer, and you can see the word customer. So this is, in a sentence, Google customer, customer engineers in the cloud team exists to build this end-to-end relationship, a technical relationship with our customers. So in this role, we do this with meetings, one-on-one. We onboard customers on the platform. We share with them some best practices to evolve, and engineer their business applications on Google Cloud Platform. So this is like more customer-facing engineer, completely different, like comparison to my previous roles.
That's interesting. So it's a mix of customer support, but with a technical twist. It's like you're directly able to answer customers' technical, requirements, their technical. So, but I'm curious, you are basically working the dream job of a lot of people. I often get DMs from people on Instagram asking me, how can I get a job at Google? How can I get a job at Apple? How do I get a job at SpaceX? Those big top 4 companies. And then I'm very curious, how has your experience been working at Google, and how did you land the job in the first place?
So before joining Google, for example, I worked for, we can say, non-tech companies. But when I was like working for these companies, I was thinking about, I really want to join a company, a tech company.
Right.
So I was a big fan before of Google before joining the company. So for example, I read the How Google Works book before joining Google. I was really passionate about like technology, and I was thinking about joining a tech company for being like close to all the amazing technology innovation. The second one is I was looking for a customer-facing role. So I really like and enjoy working with customers every day. So, and then I just went to an event and I saw someone presenting some, slides and presentations about Google. And a friend of mine, he sent me a picture on a customer engineer working for Google who was presenting something. And he told me, this job is for you because I think you really enjoy working with customers. So this is how I, discovered the job. And then I just applied and, have your interviews. What I will really recommend to someone, for example, who want to join Apple or Google, etc., I would say computer science, you have so many jobs. You really need to be aware, what do you want to do, as an individual, maybe contributor or manager, in a company. So for example, you need to be aware of the programming languages that Apple is using or Google is using or Facebook is using. You need to understand how their infrastructure works, their different teams, different products, etc. And then you just follow your passion and apply for a specific role you are looking for.
I'm glad you said that, by the way. I'm glad you mentioned that. So if you could explain to someone who's heard the word cloud for the first time, How could you easily explain that to them?
So I will give maybe the basic definition. Cloud is the on-demand availability of computer system resources, capacity, especially data storage and compute. So when you're thinking about like how can I partner with a cloud provider, how can I use cloud provider services, like GCP, Google Cloud Platform, AWS, Amazon Web Services, Microsoft Azure, or maybe other, Alibaba Cloud. You have Oracle, etc. So when you are thinking about like these cloud providers, you by default think about the compute and about the storage, and then you start exploring the different options you have via these cloud providers. So, and maybe we will talk like later about the different solution pillars, but this is how I can give you like maybe a basic definition of the word cloud computing.
Okay. And when we jumped on a call for the first time, just getting to know each other, discussing about this potential interview, you had mentioned that there were different types of cloud services.
Yes.
That of course Google was offering, but that exist in the marketplace. And those, honestly, as someone who's kind of familiar with cloud and technology, it was the first time that I hear someone speak specifically about those different things that you were talking about. For example, what's an example? It's jumping out of my mind.
See, you mean for the solution pillars? Or?
Yeah.
Yeah. So when you think about the cloud computing, first you are thinking about the benefits. Why I will use cloud computing services, right? So the benefits, one of the benefits, like for using cloud services, you are delegating a lot of staff or traditional IT staff. You don't need to buy servers. This is the promise of the cloud computing, right? You don't need to buy servers. You don't need to rent a place and pay electricity.
Right.
Have a lot of technicians. If you have any server down, you need to wake up at night and go to the data center and to and think about the scale. How you can scale this if you are like, for example, if you want to serve millions of users. So this is the first promise of the cloud. You are delegating some IT staff to cloud providers. The second one is about the cost. So, and here we're, for example, talking about the total cost of ownership. You really pay, you have this pay-as-you-go model in the cloud. And today, some cloud providers, so like GCP, you have some services where when you are really paying for, you are paying for what you are serving for. So for example, when you want to use a cloud service, in Google Cloud, you have a product called Cloud Run, and you pay only when you are serving customers from this application. So for example, if you have 0 customer using the app, you are paying $0, for example.
Oh, I like
and this
that.
is more the pay-as-you-go model. This is the pay for what you're serving for, and this is very powerful. So this is maybe the second one or the second benefit that you are getting when adopting or partnering with a cloud provider.
Just a question about that. Is the pay-as-you-go model only specific to Google? Or is it something that other cloud platforms offer? And I'm asking that because I once hosted a PDF, a book that's about 100 pages that was for the worldwide community. I was hosting the book on AWS, no offense. That was like 2 years ago. And I was paying a monthly fee. It was like $2 because the book was like a few megabytes, really cheap. But even when I was not getting traffic to the book, I was still paying a recurring fee. But that makes a lot more sense if you're saying that for every click I get or for every time someone downloads the book, I get charged on that.
Yeah. So let me maybe clarify some, the difference between the storage parts and the compute.
Okay.
So what you're saying here is storing the PDF. Storage has different ways. to store your data, and you are paying for the storage. No matter if people are using your PDF or not, you are paying for the storage. This is the storage part, and you have a different class in storage. So, for example, in Google Cloud, you have the cold line, you have the archive, you have the near line, and you have the standard. Why we have these different classes of storage? Because if you need to access often your PDF, you will pay or store your data in a specific class. If you need only to access your PDF for once a month, go for the near line. If you want to access only once a year and you want to archive, you can store your data, for example, in the archive class. And
so
again,
then the archive it's cheaper.
It's cheaper.
But then that's very interesting, and I'm trying to understand how it works. But then on Google's side, doesn't it, like for me to store something with the frontline or with the archive, in terms of Google operation, you're still storing 2 megabytes. What changes for you to be able to offer me a cheaper rates?
So it's not very specific to Google because you have the same plans on AWS. I'm not sure about Azure, but I think they have same plans. So in every cloud provider, you have different classes for storage. For answering your question, and maybe I can, I need like more time to explain the technical details, but just think about it. Like if you are, for example, storing apples in the kitchen 2 kilometers far from this room. Okay. So you need to like go 2 kilometers to this kitchen and bring the apple. But if you are like storing these apples in this room, like 100 meters from your desk,
okay,
it's easier to get this data. So technically, it works like that. It's very simple, okay, right? So I think this is the mechanism behind this. And yeah, this is for when you store data like for once a month. It's not like we know that, for example, this customer will have access to this data once a month. So then we can just like store it maybe in a place when you will have less access. So, and this is not specific to GCP because you have all the cloud providers have this different storage classes. Now compute. The compute side, because the storage you store, you pay when you access to this data. You pay for the storage first, and then you pay for the operations. You are doing operations to get in your objects. And here we are talking about like object storage.
Okay.
Objects are videos, audios, PDFs, images, etc. So this is the storage part. The compute, and this is what I was talking about with Cloud Run, is when you have a web application, for example, and you want to host this web application on a cloud provider. So for some customers, they will use, for example, VMs, virtual machines, but you need to run 24/7 these VMs if you want to host these applications. And others, maybe they will use this solution to not running any virtual machines and just serving customers from these applications, and then you are paying for what you are serving for. And if you have like 0 customers, you are not paying for this service. Okay. And I can maybe I think maybe explain more.
It makes sense. That makes total sense. So we were at the second type of service. You had mentioned there were 4, right?
Yeah.
For cloud computing. What are the last 2?
So I would say every cloud provider has at least 5 solutions pillars. The first one is the core infrastructure. You need, for example, virtual machines. You need networking. You need some security services. The second pillar will be application development, how you can help developers and operations. And here we can find the DevOps word. How you can help developers and operations to build and deploy continuously new features in your business apps. and how you can help them to have like tools for monitoring, login, all these applications. The third pillar will be databases and storage. So if you want to build an application, I think 80% you will really need a database. It could be a relational database, non-relational database. So many cloud providers have a different like options for running this database, and you need storage. So this is a solution pillar: databases and storage. You need maybe the fourth one is the data analytics. So we know that every day, if you have a business app, customers are using these applications or your application, and you are gathering and collecting data from these applications. So if you want to create value from this data you are collecting every day, you can use some cloud native data warehousing solutions. So for example, in Google, you have BigQuery.
Okay.
And this is a serverless. You don't have to manage any servers or to run any servers or to use this solution. So you can just run your queries in SQL language. So you can, for example, gather data, collect data every day from your websites, from your connected cars, from your different ecosystems or sources, and then you can query this data and do your data analytics. And yeah, the last pillar, but not least, will be the machine learning.
Okay.
So in cloud computing, you have this powerful compute to really build and serve machine learning models and add this intelligent piece to your applications. So if you think about it, machine learning is becoming more and more popular because it works differently comparison to traditional programming, right? So in cloud computing, you have this powerful compute, different methods to store more data, because in machine learning, the fuel is the compute and the data. Your inputs in machine learning is you give data, you give answers, and you have rules. In traditional IT programming, you give rules, data, and you have answers.
Interesting.
So
Okay.
if you want to make your app, there are some use cases and some business needs that you can't resolve with traditional programming. So you need to add this machine learning pieces to your business apps. So with cloud computing, you can have some pre-packaged solutions like the machine learning APIs on Google. If you want to use, for example, the speech to text or the text to speech API, you have the image recognition API. So you don't need to have an expertise. You don't need to be an expert in machine learning to use this API. So you can implement this pre-packaged solutions. But if you have machine learning engineers and you have you are building your own machine learning models, you need a way to efficiently store data and a powerful compute to train your machine learning models.
Okay. That was a handful of information.
Yeah, sorry for
No, it was great. It was great. So a common term that keeps popping up in cloud computing is scalability and elasticity. What are the difference between those two terms?
So I think in cloud computing, and maybe I'm wrong, but I don't see elasticity without scalability.
Okay.
Maybe I can give like a quick definition of both.
Please.
In cloud computing, when you're thinking about partnering again with a cloud provider like GCP or AWS or Azure, think about the scale of these companies. So Google, for example, has 6 or 7 or 8 products with more than 1 billion users every week. Same for Amazon. Think about their marketplace, Microsoft, and many others companies. Think about the scale and how many customers they are serving per day. So when you are partnering with these cloud providers to build your next generation business, you can use their expertise, and you are using their the infrastructure that they were using for 7 billion users. So you will not have this scalability challenge. When you start using the cloud services for building and deploying your business applications, you have many different cloud services that you can use for hosting your application, your databases, etc. Depending on this solution, you can have scalability method, or many ways to scale your app. You can, for example, scale your applications horizontally. You can scale your app vertically.
Can you define that?
Yeah. So, for example, when you push an application on, let's imagine you have a virtual machine and you're hosting your application on a virtual machine, but you have more customers targeting and using your app.
Okay.
So you need to add horizontally instances and virtual machines to serve these customers. So here you are scaling horizontally your infrastructure to add in more VMs and more virtual machines with your within your application to serving these customers.
Okay.
The vertically way to scale your app, and this is like this is not easy to do today with VMs, but you can do it with containers. And this is another technology was first introduced by Google in 2006, and then today you have a famous framework called Kubernetes for managing containers in production. But I'm just gonna maybe try to define the vertically way to scale. You can scale your app vertically without adding like instances or VMs or horizontal duplicate of your apps. You just add more CPU and RAM to your, for example, your VM or your container. So you are scaling vertically your application.
Okay, that makes sense.
So because when you're scaling horizontally, you are just adding the same instances with the same vCPUs and RAMs and storage. And you have a setup of instance groups, and you have many VMs with the same size serving customers. So you are adding VMs. But when you are scaling vertically, you are just adding more CPUs and RAM to serve these customers.
Okay, so I'm gonna try to give, from what I understood, I'm gonna try to give a very, very, very simple example.
Yeah.
From what I understood, and you're gonna tell me if that's a representation of if my example makes sense. So what you're saying is, let's say you had 1,000 people at location A, and you want to transport them to location B. By horizontally scaling, so you add different things, you would give, for example, 1,000 cars to transport 1,000 people. That's horizontal. But vertical, you would get one big bus.
Correct.
And you would transport everyone in that one big bus.
Correct.
Okay.
Both are, for scaling and for serving more customers or or transporting more people, but they are different. So, and in the IT world, you can scale some applications horizontally, and some applications can be better scalable with the vertical way.
So that's where you come in as a customer engineer. That's where you offer people consulting, and you tell them, for your specific case, this is better for you to scale horizontally or vertical.
Yes,
so
we advise. This is a part of the job. We, for example, try to share some best practices with the customers. We are also customer advocates. So, for example, we take the feedbacks from the customer and we share this with our product management team and tell them what the industry is looking for. So it's kind of feedback loops on the products. So, yeah, this is a part of the the job, sharing best practices, onboarding customers, showing them the different options that they have on cloud, when and where and how you want to build your business on top of Google Cloud.
Okay. To go a bit less technical, what is your favorite thing about working at Google?
I really like, the people. I'm enjoying learning every day. This is a very particular maybe job because I am working with customers every day. So I really learn every day from customers. They have different use cases, they have different challenges, they have different personalities, etc. So this is the job. I really like and enjoy working with the product engineering team and how we really accept and build, and we really we want to help customers to succeed and to serve their next billion users, etc. So this is what I like about the job, and this is what I enjoy working for Google.
I can tell you're passionate about it. Like just you talking about your experience, I can see like your eyes lighting up, and that's one thing I noticed when you came in. By the way, you're one of the first Google employees I meet.
Yeah.
And when you came in, you started telling me all those like inside keywords you use at Google. Like for example, you were looking outside and you were telling me about like some bad customer experience you got last week. And you told me the example of how at Google you called that they didn't Google.
Yeah, it's not googly.
It's not googly. Yeah, exactly.
Yeah, Google has an amazing culture. For example, if for example you help someone, this is very googly.
Yeah, this is great.
And that's great. I think you have, and this is maybe like you can find some articles about like the different tests people pass for interviews. You have a test called the googliness.
Oh.
And this is a capacity of working with people, being open, sharing knowledge, and all this. It's a good. Yeah, Google I think has a great culture, and yeah.
So how do they test your googliness?
So. I don't know if I have like mainly time to define all this, but I think the most important thing about googliness is, there are different, it's being googly, right? So
yeah, but do they, for example, do they give you a test? Do they ask you to speak with someone? Do they make
of
you
course
say something? Like how do they, like, because during an interview, the interviewer only has a few minutes to rate your googliness.
Of course.
How can they define that? How can they know that, if I hire this person today, they're not gonna be the awkward person in the office that no one likes to talk to,
Yeah.
How do you test that?
I didn't like any interview before. I haven't any interview for interviewing someone for googliness, but I'm not like a good person like to ask for this because but as I said before, like they for example will see how you work with people, how you can be open to and maybe how you share knowledge, etc. So this is more about like I can maybe share with you like more, but I'm just like you can find some definitions on googliness.
Okay.
But yeah, this is a very good. This is one of the parts I'm really enjoying, like working with Google.
If you had a tip for someone who's planning to launch themselves in the cloud industry, someone who's young, graduating university soon, or that's currently in university, what is one tip you'd give them?
So I would say the cloud industry is booming. You have a lot of great new jobs in the cloud industry. So, for example, if you want to architect your business on top of a cloud provider, you need a cloud architect. You need a cloud network engineer. You will maybe need a cloud security engineer, cloud data engineer for managing, etc. So there are some new jobs coming with the cloud, computing area, and this field is very promising. And we have some new, jobs come in for this one. I would say the first thing is consider and benchmark your cloud computing knowledge and skills with one of the highly regarded cloud certifications. So, for example, you have the Google Cloud Architect certification. You have the AWS Solutions Architect. All these certifications and trainings are very good. You can add these skills to your LinkedIn or resume, and it's not like very hard to find a job if you have these skills, because companies are more and more adopting cloud computing and cloud services. For having like a good time to market, for a good time to production, etc. So, they are more and more looking for talents in the cloud computing area. So this is like the first, if you want to be a part of the, the implementation process of the implementation of the different cloud services for a company. The second one is, if you want to build a startup today or start a business, I don't think you will, use any traditional IT, methods to do this, because with cloud you can go faster. You can really have a good time to market. You can really release new features as soon as possible. You can really compete because it's all about speed and it's all about the time to production. So if you have an idea and you really want to build this app or build this business quickly, you need to consider cloud computing or cloud providers, because you don't need to buy a server or pay electricity or rent a building for your service, etc. You just have an idea. You need some skills to maybe code your app or maybe design your products, etc. And this is the second, I would say, the second consideration regarding cloud computing.
Nice.
Cool.
Hamza, where can people find you? What is the best place for people to find about you?
So, I'm actually based in Montreal now, because I moved here like 5 months ago. I'm working with startups here and across Canada, working with startups, working with digital business or digital native companies. I am open to any like questions on LinkedIn or when people like ask me about like different cloud services. But we do have like different teams and for managing different companies. So if I'm not like, for example, gonna work with you, I will maybe ask someone to work with you because he's managing this vertical or this kind of businesses. But you can.
So LinkedIn is the best place.
Yeah, LinkedIn.
What's your LinkedIn username?
It's my my Hamza ELG.
Okay.
This is my LinkedIn.
I'll put it somewhere in the link in the podcast. Awesome, Hamza. Thank you so much for coming on the podcast.
Thank you.
It was great having you.
Thanks for having me again.
Thank you, man.